All right, welcome to Night Club. We're going to do lesson 10.3 today, which is ellipses. We don't have a lot of time, so here we go. This is an ellipse, okay? Notice the difference between the two. They're both ellipses. The first one is more what than what?
Horizontal.
It's more horizontal than it is vertical. The second one is more vertical than it is horizontal. Okay, so let's talk about the parts here. We have these points. There's 4 of them in blue. Those are your vertices. Okay? Yes, we call them vertices, even though they're not, coming to an angle. Okay? We call those the vertices. All right? The blue points. The distance from, in the first one, the left blue point to the right blue point is longer than the one from the top blue point to the bottom blue point. Yes? Okay? So, everybody just understand, from here to here, okay, is longer than it is from here to there. Everybody agree? The longer one is called the major axis. The shorter one is called the minor axis. Everybody cool? What do you think the semi-major axis is?
B. A.
It is A, but what is it?
It incorporates the focus point.
It's how much of the major axis?
Half.
It's half, okay? It's half the distance of the major axis. Everybody with me? B is half the distance of the minor axis. So here's how I like to think about it. You have a circle, has a radius, right? Okay? Ellipses I like to think of as having 2 radiuses. They have one that goes up and down and one that goes left and right. And everything in between those two is going to be between those 2 distances. Does everybody understand that? Okay? That's just what we use to draw the things. Okay? We also have these in green here, these focus points. The focus point is kind of like what it revolves around. Think of the Earth, okay? We revolve around the sun in an elliptical pattern, okay? What is the center of our universe? The sun, okay? Everything's revolving around it, okay? So the focus points would be like whatever little gravitational pull here that lets us go, okay, you can go this far, but once you get here, all right, now you got to start coming back. Is that making sense? Okay? And there's 2 of them because there's one going this way and there's one coming this way. Everybody with me? The focus point, the distance from one of those to the center is called C. So we have an A, a B, and a C. Okay? You can get C, and I want you to understand this. A, from here to here, if I took that off, if I took this from here and moved it to there, that would be the same thing. This is A. Okay? And that works every single time. So when they tell you what C equals here, it's the square root of A squared minus B squared. That sure does look an awful lot like the what? Pythagorean theorem, except it says what? It's minus. Well, it's minus because in this world, the hypotenuse is what? A, not C. Okay? You've learned your entire life, hey, C is the hypotenuse. Okay? Well, for this particular lesson, for the ellipses, A is your semi-major axis. Okay? And it serves, if you want to think of it like this, it's the distance from the focus point to the minor vertice every time. Okay? Everybody with me so far? All right. You have 2 different ways of making the equation. They're the same equation with one difference. Here, what is A squared under? The X. Here, what is A squared under? The Y. Okay? When A squared is under the X, your graph is going to be wider or more horizontal. Makes sense, right? X is horizontal. When A is under your Y, your graph's going to be more what? More vertical. Easy enough? Okay? So in other words, you put A squared under whichever way it's going. Okay? You put the B squared under the other one. The other thing about their equations, they're always equal to 1, no matter what. Okay? So, the top part, x minus h squared plus y minus k squared, that's just like a circle, right? But it's not equal to r squared anymore. It's always equal to what? 1. And there's an a squared and a b squared that you're dividing by. Easy enough? Okay? So, I'm skipping example 1 in your book. So, I wrote example 2 on here. Okay? It gives us an ellipse. And it says, write the ellipse in standard form. All right? You need 3 things to write the ellipse in standard form. You need the center, and you need A and B. Okay? So, I know, I'm going to do the part that's easy first. It's going to equal what? 1 every time. So you can write that much of it every single time, you know. Okay? It always equals 1 every single time. So, what goes in the parentheses? My what? Center. What is the center? 2, negative 4. So in the parentheses, I'm going to put opposite those, right? So x minus 2 plus 4. Okay? And now we got to figure out A and B. So A is the longer distance from the center to one of the vertices, and B is the shorter distance. Okay? So which one's longer? Left and right or up and down? Left and right. How far is 2, negative 4 away from 8, negative 4? That's 6. And you put A squared. So 6 squared is what?
36.
Now you have to ask yourself, does it go under the X or does it go under the Y? It's more horizontal, so it's going under the X. So it'll be 36. Okay? How about for the vertical part? Well, how far is 2, negative 4 away from 2, negative 7? 3. 3 squared is 9. Done. Okay? That's part A. That is the ellipse in standard form. Okay? Part B says find the coordinates of the foci. So they want us to know where are the foci? Like, I know they're somewhere in here, but they want to know exactly where are they. All right? So what do we use to get the foci? What letter? C. So I need to, oops. Oh man, now I got to draw it. This is not going to be good. Yeah, it's bad, but what it is what it is. Okay, so to get C, we're going to say the square root of what minus what? A squared minus B squared. What was A squared? 36. Minus B squared is 9. So that is the square root of 27. Can you reduce that? Yes. 27, I'll do it right here. That's going to be 3 and 9. 3 and 3. For every pair, you bring 1 out front. So 3 square root of 3. Now, do not confuse finding C with finding the coordinates of the foci. We haven't found the coordinates yet. We've just found what? C. That's all. C is what you use to find the coordinates. Okay? It is on the major axis is going this way, right? So I'm going to add and subtract C to the X part of the center. Okay? So here are my coordinates. What is the X part of the center? 2. So I'm going to say 2 plus or minus 3 square root of 3, comma, what was my Y? Negative 4.
And that's it?
That is it.
Just leave it.
Okay? Now I'm going to graph it just so you can see it visually. You don't have to graph it. Okay? But somebody put in their calculator, what is 2 plus 3 square root of 3? Somebody put it in your calculator, please.
7.19.
7.19. So here's 1, 2, 3, 4, 5, 6, 7.1. Ooh, I was very close when I just, okay. That would be 7.19 negative 4, right? What is 2 minus 3 square root of 3?
Negative 3.19.
1, 2, 3, down about right there. Does that look like about right?
Yep.
Yes. Any questions on how we did that? Easy enough? Okay. Example 3. For the equation here, find the coordinates of the center, foci, and vertices of the ellipse, then graph the equation. Okay? So we're going to start out with the center. What would my center be?
3, -4. 3, -4.
3, -4. Oops, that is incorrect. Why is that incorrect?
Good question.
Why is 3, -4 incorrect? Come on, y'all can figure it out.
Well, I said what? Incorrect.
Trash.
Oh, it's -4, 3.
Yeah.
Oh, I didn't
That's,
think
no, that's
okay.
that.
When you're writing points, X always comes first. Okay. All right. Everybody good there? Now, like I told you earlier, I find, especially with ellipses, it's easier to graph them first than it is to do the equation first. Okay? So all I need is the center, really. Okay? So I'm going to go to my center. I'm going to go left 4, up 3. Okay? 1, 2, 3, 4, up 3. So about right there. Everybody good? Somebody look under the Y part and tell me what number is there. What's under the Y? 25? So that's either A or B. It doesn't really matter to me. Since it's under the Y, I know 5 is how far I need to go up and down. Does that make sense? I take the square root of 25, which is what? 5. So from here, I'm going to go up and down 5. So down 5 would be about right there. Up 5 would be about right there. Okay?
Wait, didn't you just say it didn't matter if it went X and
I know it goes up and down because it's under the Y. That's all I said. And since it's under the Y, that goes up and down. Okay, what's under the X?
9.
9. So that means I'm going left and right. How far? 3. So 1, 2, 3 would be about right there. 1, 2, 3 would be there. There's my ellipse. I've already got the graph done. Now I just got to find all the parts. So, my vertices. How many are there? There's 4. All you got to do is name them. What is that one? -1, what? 3. What is that one? 1, 2, 3, 4, 5, 6, 7. -7, 3. All right. What is this one?
4, 6. I'm just kidding. It's more than 6. 9.
Should be 8, right? And then last but not least, what is this one?
Wait, I thought you went up 6.
-2.
Now, you can do this without the graph. Okay? The graph just sure does make it a lot easier. Okay? Here's how you do it without the graph. What was under the Y part? 25. So we're going up and down, how far? 5. So to the Y part, what was 3 plus 5? 8. What's 3 minus 5? -2. I didn't mess with the X. Okay? To get the X part, 9, so square root of 9 is 3. So we add and subtract 3 to the X part. So what's -4 plus 3? -1. -4 minus 3 is -7. Notice on your vertices, 2 of them are going to have the same, oh, excuse me, I should have underlined these. 2 of them are going to have the same Y. 2 of them are going to have the same X as the as the center. Okay? Every time. And last but not least, my foci. What do I need to get the foci? What letter?
C.
C. C is the square root of a squared minus b squared. Now, all you got to remember, do you know which one's a squared and b squared just by looking at it? You do, because a is the bigger what? Between a and b, which one's bigger? It's a. It's the longer one, right? So a squared has to be which number? 25, and b squared has to be 9. So 25 minus 9, which is 4. I add and subtract 4 to which part of the center? Not the x. Why is it not the x?
Because it's
Look at
vertical.
your ellipse. It's vertical, okay? So I take, for my foci, I'm not going to mess with the x. It's going to stay negative 4, but what am I going to do to that 3? Add and subtract what? 4. So what's 3 plus 4? 7. And then what is 3 minus 4? Negative 1. Those are my foci. Again, do you have to graph them? You do not have to, but it sure does make it, if I know, hey, there's negative 4, 7, and there's negative 1, or negative 4, negative 1. Do those look like they could have been my focus points? Yes. Everybody good? All right. Last one.
We don't have to do this homework tonight, right?
You do not have to do this homework tonight. This is what we're going to do tomorrow in class. Example 4, okay? Remember, we skipped example 1, so this is only the third example. It says, find the coordinates of the center, the foci, and the vertices of the ellipse with the equation 4x squared plus 9y squared minus 40x plus 36y plus 100 equals 0. Then graph the equation. So, we got to find a bunch of stuff. Is it in the right form?
No.
It is not. This is the general form. We need to put it in the standard form. So, here we go. I'm going to get my what together? X's and my Y's and move the number over to the right. So, 4x squared minus 40x plus 9y squared plus 36y equals negative 100. Okay? Now, when we did these with circles, we just divided everything by what was in front of x squared and y squared, right? We can't do that here because they're not the same number. And if they're not the same number, they're not circles. Okay? So, when it's in general form, I know this has to be an ellipse because even though they're not the same numbers, they are the same sign. If they're both positive, it's going to be an ellipse. If one's positive and one's negative, it's going to be a hyperbola, which we're not doing today. Okay? So, what number, okay, I'm still going to factor. Okay, excuse me, I'm still going to complete the square. Okay? But before I do, I'm going to factor. Because in order to complete the square, what needs to be in front of x squared and y squared? 1. So, I'm going to take out a what for the x's? A 4, and stay with me here. That would leave x squared minus what? 10x. I'm going to put my plus blank in there, okay? Plus, what can I take out of the y's? 9. That's going to be y squared plus 4y plus blank, okay? Equals negative 100 plus blank plus blank. Okay, and I'm messing up what I was gonna graph on, but that's okay. All right, same way we've always done it. Take your b, divide by what? 2. So negative 10 divided by 2 is 5. 5 squared is 25. It's actually negative 5. Okay. Now, here's the whole difference. Okay. Yes, we added 25 in the blank, but what did we add to the entire left side? Why 100?
Because it's times 4.
Because it's times 4. Very good, Steve. Okay? We have to do what with that 4? Distribute it. So we're not just adding 25 once, we're adding 25 4 times. Okay? So over here we got to add 100. Okay? In this one, divide by 2 squared. 4 divided by 2 is 2. 2 squared is 4. But we added a 4, but we actually added what? 36. So over here, it's got to be 36. Okay? We're almost getting close to being done. So now we can write this 4 times x what squared? X minus 5 squared. Not equals, but plus 9 times y what squared? Plus 2 squared, right? Equals 36. And we're getting closer. All right, now, last step. What do ellipses always equal? 1. So what do I need to divide by? Divide by 36. Divide by 36. Divide by 36. So we're going to have x minus 5 squared over, what is 4/36? 1/9. So over 9 plus y plus 2 squared over 4 equals 1. All right. There is our standard form. Okay? And now we graph it. So, I take my standard form, and I'm going to graph. I'll graph it in blue here. Just ignore my writing over here. So, what is my center?
-2.
5, -2. Everybody understand where I'm getting at? Here's 5, -2. Okay? So, 1, 2, 3, 4. Get out of the way. 1, 2, 3, 4, 5 down 2 would be about right there. Okay? Can I erase that and get it out of the way? Would that be okay? It takes so long for it to catch up after me erasing. See if it got everything. The plus 36 is just... There we go. All right. Let's try this again. What do we say? 5, -2, right?
5 -2.
All right. So there's my center. 5, -2, right there. Under your X will tell you how far you go what? Left and right. So not 9, but what? 3. Square root of 9. Okay? So right and left from here I go 3. So 1, 2, 3 would be about right there. And 1, 2, 3 will be about right there. Everybody with me? Under your Y tells you up and down. So not 4, but what? 2. 1, 2, down 2. So I have it drawn. I just need to label my vertices. Okay? What is this top point? What's this top point? 5, 0. This bottom point is going to be 5 what? 5, -4. The left point is 2, -2. And the right point is 8, -2.
Catherine for checkout. Mary Catherine Combs for checkout.
Okay? Last thing I need is my foci. C is the square root of what? 9 minus 4. Which is just the square root of 5. Which part of the center do I add and subtract that to get the foci? The X, because the X was the wider one. Everybody understanding that? Okay? So, y'all hush. Right here, foci. The X part of my center was 5, so I say 5 plus or minus the square root of 5, comma, negative 2. And we are done. Okay? Hope the video helped. Y'all have a great day. Stay above the line, and we will see you next time.